In today's lesson, we are going to look at the difference between simple and compound interest. Now, when we're talking about compound interest, we're going to look at it in its basic terms. We're not going to get into it in too much depth in terms of formulas and things like that. We will touch on that in a future lesson, but right now we just want to look at the difference between the two. So, the simple way to calculate compound interest. So, compound interest is interest paid on the principal and its accumulated interest. So with simple interest, we were just calculating interest on the principal. We weren't taking into consideration the interest we earned each year. The difference with this is that when we're dealing with compound interest, we are taking that interest earned into account. So the interest is calculated at regular, what we call compounding periods, and then added to the principal for the next compounding period. So for the next compounding period, we're adding the interest that we earn. So we're basically earning interest on our interest. And then a compounding period is the interval or the time for which interest is calculated. Right? So in the previous example with simple interest, it was always looking at years. However, with compound interest, you may be compounding monthly, daily, weekly, bi-weekly, annually, semi-annually, right? So there's different intervals that we may be dealing with compound interest. So let's look at a quick example of simple interest again. So we want to calculate the amount of a $3,000 investment after each year for 5 years at 8% simple interest. So my principal is not changing in all of these. It's still going to remain $3,000. That's how much I've invested when I'm dealing with simple interest. The amount that I invest, or the principal or the initial amount, doesn't change. For interest, I equals PRT, so 3,000, times the rate as a decimal, 0.08, times the time. Because we're only doing 1 year at a time, I'm only going to do 1. So basically I'm finding 8% of 3,000, and I get 240. That means that my total amount after the first year is 3,240. Now, I don't need to do any other calculations because that interest is always going to stay the same when I'm dealing with simple interest. It's not changing how much I'm making. So, uh, 3,240 plus another 240, 3,480 plus another 2,000 or 240, 3,720. And again, we just continue through this. So again, it's not an entirely difficult calculation or even table to fill out when dealing with simple interest because it's the same amount every time. Next, what we're going to do is we're going to use simple interest to calculate compound interest. So we're going to go through this. We're going to calculate the amount of a $3,000 investment after 5 years at 8% compounded annually. So that is the difference. That compounded word, or that compounded part, tells us what type of interest we're dealing with. And again, it does say that the difference is that the principal for each year is the principal that we started with plus the accumulated interest. So for example, we start off with 3,000 times 0.08 gives us 240, which means the total amount after 1 year is 3,240. The way compound interest differs is that in year 2, this amount here is our new principal. So now we have 3,240 multiplied by 0.08, which gives us how much interest we're earning. So again, the formula is not changing, just our principal is. So we get $259.2 So we're earning an extra $19.2. Our total amount, we take that amount, add it to our principal, which was $3,240, and we get $3,499.2. That, again, that final total amount after year 2 becomes our principal for year 3. So we find 8% of that, 279.94. We add that to our principal, or what we've earned over the last 2 years. We get a total amount of $3,779.14. Again, that becomes our new total amount for the next year. So again, hopefully we see how it's different. Find 8%. We should find that our interest is $302.33. So again, the format's the exact same thing, just a new principal. So we add this. And we get a total amount of $4,081.73. Again, like we mentioned, that becomes our new principal. Multiply that by 8% or 0.08, $326.54. Add that to our principal, the $4,081.73, and we end up with a new total of $4,408.27. So we can see that it is different from the previous example. We are earning more interest. Right, we're earning more interest because we're earning interest on top of the interest that we earned. And generally speaking, compound interest tends to be the one that is used more often. In terms of paying bills or in terms of bank accounts, it tends to be compound interest. So let's take a quick look and let's graph this. So year 1, 3,240. So these goes up by 1, 2, 3, 4, 5. They go up by 100. So 3,100, 240 is about there. The next one, 3,480, so just below 500. Then 720, so 720. 3,960, just below. And 4,200 for our last one. 1, 2, and we should see that this forms approximately a straight line. So this is the simple interest. It does look like a linear equation or a linear function, which we did talk about previously. Let's look at the next one, 3,240. So 3,240, we're at the same amount. Basically, we say 3,500. Very close. 3,779. So 500 or 3,779. So up there. 4,081. So 4,000. So about about over there, and then 4,400 about there. So if I wanted to draw this function, we can see that it is starting to slowly increase and get larger and larger and larger. So, which type of interest has linear growth and which type has exponential growth? Well, because we only have two options, it is easy to see that simple interest forms a linear or has linear growth. Why? And because you can say it forms a straight line. Forms a straight line, increases by a constant amount, and I would say those are two good reasons why. In terms of compound interest, there's only one option left. It is exponential. And why do we know it's exponential? Well, we could argue it's not linear. We could also argue that we see that it's going to start getting bigger and bigger at an inconsistent rate. So it's not going to be changing by the same amount. We can see that it's getting larger and larger. So we might say because it's getting larger and larger, or the dollar amount is getting larger and larger. So there's different ways that we can look at it. So as a summary, at the end of each time interval, the simple interest formula is used to calculate the interest, which is then added to the principal or the previous investment. So in your notes or your handout, you do have two examples to work through, very similar to what we were just using that simple interest formula. So I would recommend going back and taking a look at that lesson if you are a little bit unsure of what to do, and to make sure that you are using the correct formula. But again, the main idea here is just understanding the difference, or hopefully visualizing the difference between simple interest and compound interest.